Hello everyone, today we're going to discuss about antigens. An antigen, denoted as Ag, is a substance that can bind to its complementary antibody. When we say complementary, this means that generally, the antibody should be specific, such that it only binds to one antigen. Antigens also have no definite shape since it can be literally any substance. Thus, for the sake of this lecture video and other lecture videos, we represent them as basic shapes. Now let's talk about general factors or properties of antigens. Number 1, an antigen can be a self-antigen or foreign or non-self antigen. A self-antigen is an antigen found in oneself, whereas a foreign antigen is an antigen found in the environment that made its way inside the body. Take a look at this example wherein antigens can be found on our cell surfaces. These antigens, which are found on any surface of any particle, are referred to as bound antigens and can be a receptor that can bind to its ligand. This is an important concept to be discussed in agglutination reactions. Another example of self-antigens can be found as substances dissolved within our blood and body fluids, and these are referred to as soluble antigens. These soluble antigens are important to be discussed in precipitation reactions. As for foreign antigens, like what we discussed a while back, can be bound in the surfaces of microorganisms, can be found inside the microbe, or can also be soluble as found on their toxins or dead cells. Now let us discuss antigenicity and immunogenicity. Antigenicity or reactivity is the ability of an antigen to be able to bind to its complementary antibody. Previously mentioned, an antigen generally is specific to its complementary antibody, wherein their binding sites should match or fit with each other. Next, immunogenicity. It is the ability of an antigen to stimulate or elicit an immune response. A good summed up picture here is that an antigen is recognized by the immune cells such as T cells, which then activates B cells. These B cells now begin to produce antibodies specific to the antigen that elicited the response. Take note that all immunogens are antigens, but not all antigens are immunogens. This means that all immunogens are capable of binding to their complementary antibodies, but not all antigens are capable of eliciting or stimulating immune responses. We proceed to the properties of immunogens. First is molecular size. It is directly proportional to immunogenicity because larger molecules are easily detected by the immune system as compared to the smaller ones. Next, complexity of molecular structures. It is also directly proportional to immunogenicity. Complexity pertains to the macromolecular structure of an antigen. As to the order of complexity, we have first the proteins as the most complex due to having at least 50 amino acids, to be followed by polysaccharides. Then the least potent immunogens are lipids and nucleic acids. However, take note that these nucleic acids are highly immunogenic in autoimmune diseases. Third, we have accessibility to antibody binding sites, which leads to the concept of epitope. An epitope or an antigenic determinant is the binding site found in the antigen for its corresponding antibody. Basically, an epitope must be accessible to the antibody. This is more of a property of antigenicity rather than immunogenicity, but still can be applied here. If other structures block the access of an antibody to the epitope, then it is less likely to be antigenic or immunogenic. Last, degree of foreignness. Going back to the concept of self and foreign antigens, the more foreign an antigen is, the more likely it will elicit immune responses. Foreignness can be depicted by the relationship of an antigen to its host. First, we have autoantigens. These are basically self-antigens which are found within our own bodies. Normally, they are not immunogenic. Next, we have alloantigens. These are antigens of another organism coming from the same species, basically from one person to another. Examples of antigen acquisition include blood transfusions, transplantations, etc. Next, we have heteroantigens. These are antigens of another organism coming from different species. An example is antigen from dog hair sniffed by a person which triggers allergic response. Last, heterophile antigens. These are antigens coming from unrelated species but similar in structure such that an antibody specific to one may react or bind to another similar antigen known as cross-reactivity phenomenon. Let's proceed to antigen structure. It is classified into complete antigen, which is composed of an antigenic structure and an immunogenic structure. Antigenic structure is usually what we call as hapten or the epitope itself. Immunogenic structure is referred to as the carrier molecule. The carrier molecule helps the hapten to be recognized by the immune system through its large size and stimulates the immune system to produce an antibody complementary to the epitope or hapten. Next is the incomplete antigen, which is composed of hapten or epitopes only. A hapten can bind to its specific antibody but cannot elicit an immune response to produce it. It needs a carrier molecule to be large enough for the immune system to recognize it. That's it for this topic. I hope you guys learned and enjoyed.